Welcome to the Tracing References to Interlaced Objects video. This will demonstrate how you can use AQtime's reference count profiler to track references to COM objects. COM specifications require that an object remains in memory as long as there are clients which are required to access it. Once all the code that uses a given COM object is finished running, then that object should be disposed of. Now, to determine the object's lifetime, COM uses reference counters, and reference counting is controlled by two methods, AddRef and Release. And the workflow goes something like this. When a new client acquires access to a COM object, the AddRef method increments the object's internal reference counter. And when the client is finished using that COM object, it calls the Release method, which decrements the reference counter. When the counter reaches 0, the object is no longer required and can be destroyed. Now, some high-level programming languages, like Delphi and Visual Basic, provide automatic reference counting. In these languages, a new reference is added automatically when an object is created, and when the object goes beyond its visibility scope, the references to it are automatically removed. Thus, COM objects are typically used without explicit calls to the AddRef and Release methods. However, there can still be situations when you need to call those methods manually. Other programming languages, like C++, require programmers to perform the reference counting themselves. Either way, each call to the AddRef method should have a matching call to the Release method. And if the number of AddRef calls exceed the number of Release calls, an interlaced object will never be freed, thus causing a memory leak. And if a Release is called more times than AddRef, then the reference will be destroyed prematurely. This can lead to an access violation when a non-existing interfaced object is addressed. AQtime includes a special profiler, the reference count profiler, that can be used to trace references to interfaced objects. This profiler monitors the calls to the AddRef and Release methods and helps locate unreleased or prematurely released objects. I'm going to demonstrate how to work with this profiler, and in my demonstration today, I'm going to use this reference count demo application. This application initializes some interfaced objects, but does not release them by the end of the test run. So we'll see how AQtime will help us find and eliminate those non-released references. Okay, so the first thing we're going to do is create a new project for profiling our application. So to do that, I'm going to click this Create New Project from Module button right here. And then I'm going to browse out to where my executable lives. In my case, it's right here, so I'm going to click Open. And now AQtime is creating a profiling project for this application. So now what I want to do is profile the application using the reference count profiler. So I'm just going to make sure that the reference count profiler is selected from the drop down here. And then I'm going to click this Run button. Now AQtime pops up this Run Settings dialog. And the most important thing to keep in mind here is this Collect Stack Information setting. This specifies how the profiler should collect information on call stacks when creating objects. And I want to make sure that by lines is selected here. This means that the call stack entries will include information about routines and their source line numbers. So now we're ready to get started, so I'm going to click the Run button. And now AQtime launches my tested application. Now what I'm going to do is enter the number 3 into this text box right here, and then press the Execute button. And what this is doing is it's telling the application to create one container object and 3 items within it. And once I've done that, I can close the application, so I'm going to click the Close button. And now AQtime is going to generate some profiling results and display them on screen. Now AQtime organizes profiling results into 2 categories, classes data and objects. Now, the classes data category provides information about classes whose instances remain in memory when the results are generated. And here, in the results, we can see that there are 2 classes whose live count differs from 0. This means that these classes' instances were not destroyed when the application was closed. So to obtain information about a particular class instance, I'm going to select the objects category in the Explorer panel and have a look at the Report panel. Here we can see information about the objects that remain in memory. AQtime reports on the total number of objects that remained in memory, the live amount of objects that are still in memory here, and the peak references for each object. To obtain detailed information about these references, I can select an object and then switch down to the Details panel right here. This creation call stack page displays the sequence of function calls that created the object. The references page contains information about the calls to the object's AddRef and Release methods. Using this information, we can quickly find code statements that increased or decreased the object's reference counter. For example, to find the code that adds the first reference to our unreleased object, I'm going to select the first AddRef method here in this references section. Then I'm going to look over here in the AddRef and Release call stack, and this table displays the sequence of function calls that led to the call of this AddRef method. The topmost method in the call stack is the internal ATL method that called AddRef. Now, I'd like to look at the source code of this particular method, and I can see here in the source file column that the method was called from the atlcom.h file. So if I want to inspect that, I'm going to need to specify the path to that file in AQtime. So to do that, I'm going to come up here to Options, and I'm going to select the General Search Directory entry, and then I'm going to click Get Defaults. And then I'm going to select the Visual Studio 2008 entry. Click OK, and OK again. And now we can view this method's code in the editor panel. And to do that, I'm just going to double click this row right here in the table, and AQtime brings up the editor panel and positions the cursor in the corresponding line. So we can see the code that actually called that AddRef method. Now, to know what code in our application called this internal ATL method, I'm going to go through the call stack. So I'm going to flip back to the details panel here. And we can see that this method in the top row is called by this method here, which is called by this method, and so on. So in this way, we can establish that the AddRef method is actually called in the result of the createItems routine right here. So let's view the source code of that routine. I'm just going to double click on it. And as you can see, this code calls the query interface line right here. And that method retrieves a pointer to the interface on the item object. This method calls an internal ATL function that actually calls the AddRef method. So in this way, using the information provided by the details in the editor panels, you can trace how the object references were added and removed. You should remember that each call to the AddRef method should have a corresponding call to the release method. So once you find the AddRef call that does not have a corresponding release call, that means you found a leak. So to fix the leak, you need to call the release method in the appropriate place in your code. You can also use the call graph panels to view how the reference counters were modified during the application's execution. So here, what we're going to do to start with is go up here to Options, and I'm going to come into this Analysis Results Call Graph, and I want to make sure that this number of child levels value is set to 50. Okay, so once we've got that done, I'll click OK. And now I'm going to click on this call graph palette down here. And what this is showing us is a graphical representation of our code. And so I'm going to scroll over here until I find the call items, create items there, right there, okay. So let's trace the modification of that reference counter for item 2, as you can see is highlighted up here. All right, so as we know, the first reference to this object was created in the execution of the query interface method that got called in the createItems method, which we can see right here. Okay, now these rectangles that you see highlighted correspond to that method, and then in the lower part of the rectangles we can see some information about those methods. For example, here in the bottom part we can see that assign controller to items was called twice, and you can see this little number 1 and this -1. That's saying that the counter was incremented and then decremented, so we are totaling out at 0 there. So okay, so if we look at create items, we can see right here that we have 2 instances being created, so the reference counter is 1, 2, but there's only one -1, so our reference counter is not being destroyed properly. So I can view the source of the createItems routine just by double clicking on it right here, and again AQtime brings up the editor panel and positions the cursor on the problematic line, which is right here. So here we can see that our first reference is added when the query interface function retrieves a pointer, but then there's a second reference being created here when an item is actually added to the container. So now we know that there's a reference to the item object being kept by that container. So now let's review the results collected for the CC container object. I'm just going to double click on this guy right here, and then we will take a look. AQtime is reporting 3 unreleased references to this object. So if we review the hierarchy of function calls here in the call graph panel, we notice that all 3 of those references were added by this assign controller to items function. So this function calls the put controller function for each item, as you can see right here in this column. And what we want to do here is check out the source control for this guy. So I'm going to double click the assign controller to items code here. That jumps me into the editor. And you can see right here on this line that's highlighted, we can see the code that's being called from this method. So as a result, each item object obtains the reference to the container object. Thus, what we have here is the container has references to each item object. The item objects in turn keep the references to the container objects. So it seems what's happened here is that we've forgotten to call the method that will clear the container object in our application. So now we want to correct that mistake. Okay, so I've already opened the reference count demo solution in Visual Studio, and I've opened up the reference count demo CPP file for editing. And what I've done here is I've browsed down to the event handler for the execute button. The handler here calls the methods that create the container and the items objects. It also adds the items to the container and assigns the controller to the items. But this is not the full life cycle of the objects. There's no method that releases them after they've been added. So what I want to do is call the clear method, which will remove item objects from the container. So we're just going to add in this single line right here. I'm going to say container clear. So now when this method gets called, the container class will release references to the item objects, and items in turn will release references to the container. Okay, so I've recompiled my application, I've switched back into AQtime, and now I'm going to reprofile my application. AQtime will automatically pick up the new debug info for that app. It's going to take in the same settings as we did previously. So we're just going to wait for our application to load, and then we'll enter 3 in that field again. Okay, so here we go. We're going to put 3 into this field right here. We'll click execute, then we'll close. AQtime is going to generate our results. And this time around, you can see that the classes data panel has a live count of 0. That means that there were no objects left in memory after the application was closed. And if we come here to the objects pane, you can see that's blank because, again, no objects were left in memory after the process was closed. So that means we've eliminated our leak. This concludes our video on tracing references to interfaced objects. I hope you found it helpful. If you have any questions, please don't hesitate to contact us at the URL on your screen. We wish you luck and hope you enjoy profiling your applications with AQtime.